Hi fam, I'm Nathan. Welcome to my very first video on Solidity. In this video, I'm going to show you how you can write your very first smart contract using Solidity. Without wasting much of your time, let's get started.
So we'll begin with the Remix IDE. We'll be working with Remix IDE. You understand? It's a free open source IDE for writing Solidity. You can either use the web form, which is this, or you can use the application itself, desktop application installed on your system. So I'll be using this so that in case you want it to be saved, you can always come over to your PC and check it out. So we'll just be creating a simple smart contract that would actually add the sum of two variables. You understand? And would first of all start with creating a file. I will explain every bit of code I'll be writing here. So stay in touch and let's get started. So I'll begin with this creating a file. We will name it a simple smart contract, just like that. Just it's not anything much. Dot so I will explain why we are saving it with a file extension called dot so. Now in Solidity, it is expected for you to save stuff dot so. Why is it so? Because Solidity basically the source codes files are actually saved in the file extension dot so as the standard convention used for Solidity compiler. So compilers on Solidity, the compiler on Solidity recognizes .so as the formal way of using extensions when you want to save Solidity projects. You understand? It actually helps to identify and compile the smart contract correctly. I'm trying to explain it in a low level form. So it's more like you finding the right pieces that will actually make you get your whole day going very well, your agendas and all. So making sure to get the right equipment, you understand? If you don't have it, then your task for that day definitely might not be accomplished. So compiler on remix the on Solidus rather, the .so file extension is the recognized compiler. You understand? For saving Solidity project. So let's begin by writing the code run. So first of all, if you want to start writing codes on Solidity, the first keyword which you should include, the first one as a Solidity programmer or Solidity Smart Contract programmer, you would actually start with using Pragma. You can see it's popping up. I will explain everything like I said. So Pragma Solidity. Then you add the version you want, the version you want to actually compile, the version you're actually looking for. So right now, Solidity has version 0.8.30 being released already, properly working, and currently the current version, which like I said is 0.8.30, which is running perfectly, is the one. This code specifically, what I just wrote, the program itself, it's this is just using Solidity language, the program Solidity dot version type. It's actually used to specify the compatible version. This code here, it's used to actually specify the compatible version required in a compiler in order to actually compile a source code. So it's more like you trying to look for the right ingredients that will match the dish you want to actually prepare. You understand? So now, what is the pragma itself? Pragma is just a keyword in Solidity that is used to specify the special instruction. No more like, you understand? It's just used to specify the special instructions for the compiler. You understand? About how to treat that source code. It's just a keyword used to specify the special instruction about that source code itself. Now, the Solidity itself as well, this actually indicates that Pragma is just the Solidity language compiler, more like, you understand. It just specifies that it just indicates that the Pragma is just a Solidity language compiler. So this 0.8.30 is the version you want to run. It's just the version you wish to run. So I'm trying to explain everything bit by bit so that you understand why this code is running this way and that. So the next thing we're going to write is the fundamental key block for Solidity, which is contract. Then we'll put the name of the contract we want. You understand? We want to define. That's declaring the smart contract with what we want. So we'll be using simple smart contract. I just want to use this as what we named curly braces. So this is just the fundamental building block for Solidity language. It's more like used for creating apps and blockchain platforms on EVM chains. Understand? On EVM chains. So the name which I said simple smart contracts, yeah, is actually you trying to declare the smart contracts. You understand? The name you want to declare. If you actually been a programmer, you would understand why this actually was being made this way in the simple form. So after using the keyword contract, you now identify the name you want to name it, which we specifically will be naming it simple smart contract. So it's just a fundamental building block for writing Solidity language. So next would now write the code, what we want to solve. What we want to solve basically in order to see it running. You understand? So first of all, what we'll do right now is to actually, since we are trying to write a program that would add the sum of two variables, we would declare the variables inside this building block, which includes unit u int value. Let's save it this way: value a equal to, let's say, tw- 2. Let's say 2, just to be simple. And u int value b, just to be simple. We put 80, 63, 63, 63. Just leave it this way. So as you can see, it gave us an error. Don't worry, we're going to solve it. It's normal error. I would actually show you and identify the error ASAP. So okay, let's continue. So before I don't know if you've seen the error. I already know the error, but I just want purposely did this so that you actually know that once you see error, just don't actually feel afraid. Try to know the reason why the error happened and solve it. As you keep going, you will get to do your stuffs. You understand? This is how you actually do a lot of stuff as a programmer. So now this error is just me not identifying the uint very well. So this is how you actually put it uint. You understand? And it's okay right now. So the next thing we've just declared, I like using comments on my program. So I'll write a comment for you so you understand it very well. Okay. So this is just we trying to declare a variable. This is where, sorry, this is where you want to more like mostly declare a variable which which we just did. So um this is just it. No problem. Let's work with this way. So okay. So next thing we would have to do is to create a function that will add the two variables. We would actually create a function that will add the two variables. Now, before I head over to that aspect, what is uint? Why did we use uint specifically? Let me explain. The uint itself, it's more like a in like you defining a variable in an integer form. I don't know if you understand. Uint, it's more like an unsigned integer specifically. An unsigned integer specifically. We are assigning an unsigned integer as an initial value of 2 and also as an initial value of 63 for the two different variable we declared. Now, that's just it. So the next thing we're going to do is to actually write a function. This function specifically will add the variable which you want, and this particular stuff we're trying to write. This function defines the program itself, what we want to actually work. You understand? On. So now I will say function add values or variable or value, just function add, so that you understand it better. I would actually say public view. I will explain this. Return uint. You need to return it uint. Don't worry. Like I said, when error pops up, you try to solve it. Now, if you watch, expected curly braces, but got simple smart contract of this function, said function add public. Let me scroll so you see it very well. Like it said now, the problem currently, I can actually view problem alt plus F8 and it to solve it automatically. But the problem comes with just X. You add the X to return everything basically. So I prefer trying to solve my errors myself instead of just using that alt this thing for the compiler to work on it. No, most times I do it myself. So okay, so next thing we're going to do, I will explain this right now. So this stuff we just defined, this function add this, it's just where just it defines a public read only function. The view you see there is a read only, like it's just it's just a keyword that specifies that the function will not modify the contract state variable, more like, you understand, even when it's called externally. So view functions do not cost any gas fee. Understand? So I'm just using it. That's the reason why I'm using it. Now the function add results. That's the curly braces there. The function itself now declares a new function named add. So the public itself there is just a visibility specifier, which means the function can be called from within and outside the current contract. You understand? And from external contracts. So the return on open brackets uint. You understand? The return open brackets uint, which we just specified there, has its own work. More like, so it just specifies that the function will return a single type of unsigned integer, which is uint. Just return if you want. Okay, let's say now, if there is another this thing we define, if it is another type of integer we want and we use another type of integer, we have many of them, then you have to declare two and put the other one comma something. You understand? So but we are working with this uint. The two of them are declared with the same type of unsigned integer, so we just put it. It is going to be recognized as the same. So next thing we're going to do is to actually write the main body of the function body, what it will sum. So what we'll just do here is to return, that's to break the function. So in order to stop here, you understand, like it will just break off the function and give us the results. So return value, let me just place this, plus we are trying to sum value b semicolon. Now this is it. Now this we just wrote, which the last this thing we just wrote, which is return value a plus value b, has what it does. Now we are trying to say it should return the value a. This is just the function body which calculates the sum of the two variables and return the result immediately. You understand? Returns it immediately. Now this is what we want to work on, and this, yeah, like I said, let me define it this so you understand it. In case this is just the function body, more like where we would actually declare the sum. Yeah. So this was this where we wrote this return list, and that's what we wrote. And yeah, this pragma, like I said, if you could remember, I said it is always going to be there. It is always going to be there. It's a keyword being used. You understand? So I would actually run the code. Let me save, and I'll actually run the code. I'll compile it. Compiled. Now let's check what it will return on the smart contract. Let's see what happened. I'll run it. Compile and run script. That's what you do if you want to compile it. You see what happened? Warning: SPDX license identifier not provided in the source code. Now, this is one thing you need to add specifically. It actually helps them, like, to know that okay, this is the specific, you are specifying a license which is actually being used. Now let me do it right now so that the error will go off. So I will type this, which you can see what happens. It shows. You understand? This is how you just solve it immediately, and boom, the error is gone. Compile. You can't see the error again, right? So that's it. So let's run the code and see what to give us. Compile the code. So that place I just set some stuff. Now let's deploy. This is where we'll deploy it. Deploy. Now this is the contract we just deployed. Let's let's check. Let's check. This is it. Default. This is it. So when you click this is the function, this add shows that okay, this is the function you are trying to run. When you click add, it will give you in 60 you it's 22 256 65. The results here 65, like we said, 632. Like you're trying to calculate two variable. If you change this to 80 and compile, because you have to compile, you will have 82. So let's deploy again, because you need to deploy again in order to see. So let me remove the last deployed contract. So let's deploy again and watch this. See what will happen. Add 82. So yeah, it says you actually deployed a this from our address. This is the address to simple smart contract dot add data. This is the address. You understand? Defaultly. So this is just a smart contract that sums two variable. So what this does, like I said, is we trying to calculate two variable and it gives us the sum. And with this, we've come to the end of this section. So I do hope you understand what we just did and see you on the next solidity section. So thanks for watching and subscribe.